I'll say it at the end. Normally I do, but we're already just bullshitting and talking. Okay. All right. So this is a recirculating dust collecting system. It has a couple floor sweeps, which are these guys, and a number of drops. This is a constant volume system, and so, but we look in here, and you see the VFD. The VFD is for balancing only. Once it's set up, it just stays that way, because this is a direct drive system. So there's no belts, no pulleys to adjust. And the airflow on this thing is critical. You know, it's all engineered, and my experience, which is, you know, I'm not dealing with the operation of it, but when I see in the beginning, when I've been around or see it balanced, just to happen to be around when the balancer was around, they're engineered typically very tightly. You know, it's they're designed to work, so that if something gets out of whack, then there's more problems. It just cascades. Okay. And so this VFD is designed will be set by the balancer for a specific amount of airflow. And there's drops, well, here we go, this guy. This is for balancing. Once they're set and closed, they're not supposed to be moved. And people like to go around and close things and change things. You can do that, but you'd have to have somebody look at it. Somebody should say, you know, you can't do that much, or like the floor sweeps are open and closed. That's normal for them. So the engineers take that into consideration. That's not going to be a problem. But if you cut down too much of the airflow, then the main trunk, which is this guy, allows the dust to settle in it. And if that happens, then that's you know, that's what burns, that's what causes problems. I don't know of any problems in schools. I mean, factories have problems. Dust, you know, grain elevators have problems. But schools just don't, it's a precaution. But the idea is that the airflow has to be set by a balancer and stay that way forever, okay? So
will they'll set the parameters, and once that's done, we tell the teacher this is where it's got to be.
They shouldn't, yes, they shouldn't open and close these whatever you call them. There's a name for these, like guillotine switches, the baffles.
Yeah, so if they're closed, don't open them?
Well, it's where they're going to be some position, because the balancer will adjust them.
So when they do that, then they lock that in,
right.
And that's where it needs to stay.
Right, and the system, you know, my guess is the systems are more forgiving than people say, because as soon as you tell people typically you can do a little, you can do that, people just go nuts, and then the whole thing goes crazy. Gotcha. Yep. So it's sort of like telling people not to look at the robin's nest, because the robin can smell the fact that you've been. Robins don't smell anything,
right?
You know, but it keeps people from touching stuff. Yep. So yeah, there's some flexibility, but they'd have to ask somebody, basically, you know, and say I want to do this, and then somebody would look at it. Okay. So let's take just the front cover here. Well, let's go to the overall system. It consists of the main panel, which controls the blower itself, and there's also a shaker out there. And this is for the shaker motor, and these are timers. There's a wiring diagram. Well, there was. Maybe it's in one of the other panels. Maybe somebody took it. But there's a wiring diagram, and you should have that. Now, you won't be fooling around with any of that stuff. But when somebody comes, if they can't find a wiring diagram, then you're talking about, you're tripling the amount of time it takes to fix something. So you shouldn't have to do anything with this. One nice thing about this, there's lights on all these things, so you can tell what they're doing. If you have the wiring diagram in front of you, you can see what's happening. But again, you shouldn't have to deal with any of that. You will be dealing with this. When we go outside, there's a photohelic outside, which is, you know what a photohelic is? It's a pressure gauge that is actually a controller. You just you read it, yeah. And that's one of the things that had to be rewired. I don't know whether they were successful or not, but I can tell you how, what it did, or what it's supposed to do, and we'll try it, and it may work. When the photohelic is a safety device that reads the pressure difference across the second set of filters outside. There's a primary set, and that's these bag filters. and that's what shakes, and then dust falls into the barrels. This works on a filter that's above that, and it's a secondary filter, but my understanding of it is that it's a wire mesh filter, and it's not designed so that if something happens to the lower filters, the bag filters, they start to come apart. Like if they get wet, then they tend to get weak, and eventually they go and they'll end up in the blower, and they can damage everything. So this is sort of a safety, so that if it detects blockage, because this is not fine filters, these are like metal mesh filters. They're designed to catch pieces of big stuff that's flying up. That'll shut the unit down. Okay. And this tells you that the unit's shut down.
And that'll light up? That
lights up. So it makes service. And you're correct, this is more of a maintenance thing. Okay. It's not maintenance really, but it's the kind of thing that it would be an active interface with people that are dealing with it at all. Yep. You know, that lights up, that's why it's not running, you got to figure out why. And we'll look at that outside. This is the reset for it. So that when you figure it out and correct the problem, then you can push this button, the light will go out and it'll run. Okay. If you turn it off, it'll reset too. So, and now there's two places to start and stop this thing. And this is one, and that's what this refers to. This is a dust collector control. Local control is here, start and stop.
Like manual.
Right. And then off, nothing happens. And then remote, see by the door there, to the left of the door, there's that red button we run. That's the same as this. It's a momentary switch, both of them. So, but you got to be at, to the right place.
So with it in remote, can you use both?
No, you can only use the remote one. Okay. That's right. Okay, so, and local is this guy here. So there's two more controls. Let's take a look at those before we try anything, before I run anything. Oh, this is a good sign. This was on fault when I was here before. There was a problem. So maybe they fixed. They told me they had done some things. Apparently they did the right thing. Okay, these are two separate sort of control systems in a sense. This is a spark detector system, okay? And it is, let's see, right above it, you see those two black on the opposite sides? Yep. That's they're spark detectors. And they're across from each other because two reasons. There's actually one primary reason, is they test each other. So you don't have to go up there and just try to decide whether this thing's working or not. And I'll show you that when I'll go through the whole thing first, then I'll actually push buttons and we can look at stuff. So this is the spark detection system. If it detects a spark, excuse me, up there, it goes through a series of events, one of which it shuts the blower down, two, it puts water into the ductwork. And it's right,
oh, wow.
Let's see, where is it? Maybe this one may be outside.
Outside, yeah.
Yeah, you can see I tested it, so I know it works somewhere, and I could hear it, so it should be right in here somewhere. No. Okay, it has to be out there. It is supposed to be some specified distance from the spark detector. Okay. This unit, I think I remember seeing it's like 23 feet or 26 feet, so it would be out there. The idea being, if it detects a spark here, knowing how fast the flame would be propagated in the conditions that this runs in, like wood as opposed to metal filings, which you don't see spark detectors on metal filings. But they would know, okay, we've got this much time, we have to allow this much time for the system to sense it, to turn the water on, so that when that fire reaches the sprinkler system, it's functioning. So the distance is a critical distance. And it's been set and it's right, okay? And then there's a distance after the sprinkler that it's supposed to have before it, I think goes into a 90 or something. It's so that the water coming out of the sprinkler, which is designed to expand and cover the whole duct. So it needs to do that in a straight section of duct. So they're all set, and I've checked them, they're fine, they work. But that's what it does. So it detects a spark, and initiates water, a horn, which we'll test, and it is just piercing, shuts the unit down, And what else? There's something else. Oh, there's a damper, which we'll see, where there's also a problem connected, hasn't been fixed yet. We'll see that. And it's an abort damper. So that if there's the fire gets, or either starts or gets into the dust collector itself, that it can't get back into the space. So it redirects the air. So the air, instead of coming back into here, is directed up into space, and we'll see that outside. And it's a great big damper that swings down and makes a bang noise. And the problem is that when the electrician put the conduit, which is the connection between this and it interferes with the handle on the outside, so it doesn't let it close all the way. So it's not going to work right. So he moved it some, but not enough. So that's one of the things we'll see. So that's what this guy does. And I'll show you, this thing has a testing thing that you just push buttons, and it tests itself. It's very nice. It works, and it works well. It's extremely sensitive to the DC voltage that the signals, these spark detectors are DC, and because it's got this computer in here. Oops. That board, the board's all DC.
Okay.
So what has happened, and I've seen it happen a few times, is that if the high voltage wire, it's 120 volts, if it's AC wire, the worst case is if someone has put it in the same conduit as the DC, it will tell this thing that this gets confused, and it gets that, it interprets that as a fire. So it sets off alarms. Now, I don't know what, I haven't talked to any of your alarm people, and that's something you might have to get involved with at some point. And I'll show you when we do this, it has a couple ways that it notifies, it can notify the building. It's hooked up, so they're using it. Some school districts don't use it. It's just standalone for them. But if that, which I don't think it does, and actually, this would be all your job, I can test this, but I'd rather have you call somebody and have this thing be put on test. Because if somebody hasn't done something right, and it is connected to the fire system directly, then it calls the fire department. And I know of one case where that actually happened, cleared the school out, and so, it's unlikely, but it's a mess. So at some point, if you could just have them put it on test.
Yeah.
For an hour.
I'll have to pass that to the electrician. We have a district electrician that's specifically assigned to this site, and he handles all the fire systems.
Okay, if you could get a hold of him.
I'll definitely do it. He's not here today, so I'll definitely, but when he comes back, or I can pass it on to my
Well, the thing is, I can, since I don't know what he's done, I can pull the terminals. However, some of the fire systems will detect that as being an error, and it sets the thing off anyway. So we can maybe just talk about that aspect of it.
All right.
Okay.
Yep.
But that's part of the test routine. Yeah, we won't deal with that.
Okay.
Let's see. Okay. Okay. So we'll go into this. When we actually run this thing, I can go into some more specifics. This is a controller for another safety device that is it's like the abort damper, which is the air coming back into the space. This addresses the air leaving the space and going to the dust collector. And it's called an NRV, a non-return valve, so that it doesn't let the air return from yes, it does. It doesn't let it. That's right. It doesn't let the fire come backwards. Okay, and this. Let's see. How did that happen? I think there was a couple of problems with this, and one of the things it does, it also shuts off the unit as well. So for some reason, this was the only thing. Like there was a fire out there, and this not a spark detected. This thing will shut the unit down as it detects the reverse of the airflow, and we'll look at that outside.
Question on this.
Sure.
So the test you can do maintenance-wise, is there something on our end or a amount of time that we should be testing this, or?
There's a manual, and the manual is quite good, and like most manuals, it gives you 5 times what is necessary so that when there's a problem and you end up in court, and somebody says, well, did you look at it every morning between 9 and 10 o'clock in the morning? Well, then that's the whole problem. So yeah, there's a schedule, again, if you do it at all. Because on this thing, I'll show you, there's a testing, you just push buttons and stand here and it'll test itself.
Yeah.
You know, so, but again, somebody's got to do it. And if you wait until there's a problem and it doesn't respond,
Right.
then the questions start, well, when did you check it? So it's, well, it's like a lot of,
That could be
there's,
something that we'd pass that, down to the teacher? Or should we?
it
have a
depends on
schedule for
how,
maintenance?
part of it depends on how reliable the teacher or the maintenance people are, because as you know, it's highly variable for the individuals. You got 10 things to do. You know, what do you decide to do? Well, some things end up at the end and they never get done.
Yeah.
So some of these are, you know, life safety things,
So
which
that's
it,
kind of a priority.
yeah, but it says, it just needs to be, like, if you were to do it once a year, I think that would be fine. Because it'll tell you if there's other problems with it. It has a trouble light, and it'll tell you not, we'll talk some more about that, but the trouble light just says, hey, something funny happened, but it's not going to shut the unit down and set off the fire alarm and everything else. So it has some capability, like it'll beep at you when it does this trouble thing. You know, so it has it's not completely mute until there's a problem. Right. So, but once a year, I would say, something like that. You just come and go through it, and it doesn't take long, but it just needs to get done.
Right.
This guy, as far as I know, it probably has the same kind of thing where there's stuff to do, but this one is basically completely automatic. See, there's no buttons. I mean, these are just, you know, notification things. There's no buttons to turn this thing on or off. So, and also, which is not your issue really, but these are all dedicated circuits. So that it's not hooked into something else and somebody else decides they want to work on a fan that's hooked in and they shut it off and now they're shut off the fire alarm system or stuff like that. So both these, this one has one dedicated circuit just for its power supply, and this one has two. One for the board itself, the controller, and then one for that damper. Mm-hmm. So the damper, it has a solenoid on it that it holds that damper open. So that's a high voltage, and that's also so it has its own breaker. You know, so okay. Let's go and take a look at the unit. Yeah. Okay. Okay, so there's the ductwork, obviously coming across.
There's the water.
Yep, there's the sprinkler. It doesn't, you can have angles and stuff in the incoming ductwork. That's not the issue, it just has to be a certain length. And that's that no return.
That's a damper?
Yes, that's the no return damper. And let's go around the other side and you can see. Now, see that weight, that counterweight?
Oh, sure enough. Yep.
So the damper is, basically on line with that handle going down.
Uh-huh.
And looking at it literally is blocking a significant part of the duct right now. But it's pivoted on the shaft. The counterweight is to sort of equalize the weight of the damper, so that it's sitting there floating like this. And there may be, here's the bottom of the duct, here's the bottom of that damper. And there's a space, and it's quite restricted. But it doesn't really restrict the whole system very much. And in fact, an individual, like those dampers that we looked at inside, those volume control things, they really have remarkably little effect. You can close them halfway and you get maybe a 10% reduction. So it would seem that would be much more restrictive than it is. But it's basically floating in there. So that if the air goes in the opposite direction very easily, it comes down and it closes. And you see that thing, the handle with where you put your fingers, that will swing down, not the handle, but when that air pivots and closes the damper, that will lock in place.
Okay.
So then somebody has to go up, and that's where that handle, you just pull that handle out, and it releases it. It'll just go back up. So let's see. That was one thing that wasn't, there's a disagreement as to who is responsible for wiring it.
Gotcha.
So that's been resolved. And you can see, if you look right in the middle of the bottom of that thing, you see a piece of plastic about length from here down sticking out, and it's wired. It's hard to see because there's a wire coming out of the end of it, and it goes into that the box there over to the right. That's a sensor, and what that sensor is for, it's a dust level sensor, so that if dust is building up in that control for whatever reason, the airflow is inadequate, or there's sort of eddy currents, not eddy currents, but there's a lot of turbulence in there.
Yeah.
So dust, which ordinarily in a straight piece of pipe may just go flying along, it may end up building up there, and that's not desirable. So that thing will sense that there's dust, and it will show up as a fault. Remember on the front of that box, it was some OK or whatever it was,
Right.
and the other one said fault. Should turn that light on, and you have to go out and clean it, which is not that easy.
I was just going to ask, is that, so that is sensing just in the damper?
Yes, it's just right where it sits. It sticks up an inch on the inside, and if the dust ever reaches 1 inch, it'll I don't think it shuts the unit off. It just says there's a fault.
Says the alarm, okay.
If that damper comes down, it will shut the unit off.
Right.
So on top, there's a plate with like 16 nuts, studs and nuts. You can pull that off and then you can clean it.
On top?
Yeah, you're right. If the system is working properly, I don't see that would ever be an issue. But there may be other circumstances with other materials. They've had a problem with that, so they put that in there. Let's see. And the other one, actually, the black, the SO cord, the black cord that goes up, you can see the black, come on over here. That's a second sensor. And what that is, it's one of these sensors on a roller, like if there's something coming along and it sits on a roller. And if there's like a production line, if there's something in it, it'll hit that roller and the roller just lifts up. That's what that is, and it sends a signal to the panel.
Fault.
So when that rod swings by and hits goes by that roller, it tells the panel. And that will automatically reset itself when you pull that handle.
So is there a way to identify which issue it would be?
I'd have to look at the wiring diagram to see. There's nothing, the lights we looked at, they don't tell that. I think the issue is you're going to have to go look.
Yeah.
Well, in fact, it's easy. You go out here and look, and if that handle is more vertical, then it's the handle. If it's off, well, of course, there could be something wrong with it, which is a whole other issue. That's more of a service issue. Then it would be the other one.
Well, chances are, if there's ever an issue, we're calling somebody.
Yeah, right.
So.
But you get an idea. Some of you can take care of.
Yeah.
It's just easy.
That's what we kind of were looking for.
Yeah. Okay, so we'll go inside in a minute, but you see that big yellow guy?
Yeah.
That's the other one. That's the abort damper. And this is blocking the air that is normally going out to the dust collector. It blocks it from returning. That's the one the air that's normally going back to the space from the dust collector. That will divert that. And see that hood? We'll see it better from inside. The hood diverts it that way. Okay, so let's go. Oh, and these big guys, that big box, that's the sound attenuator. These units, they move a lot of air and they're big and they tend to be noisy. So these are efforts to quiet them. Yeah. Okay. Now, just basically what we're looking at. This is the body of the dust collector. In here, behind these doors, which are open, is the bag filters. This is a shaker motor, which is just an eccentric. It's a round thing with a pin, and when it spins, that pin's going like this, and there's a like this, and as that goes around, it just makes this. It converts the circular motion into a linear motion, and we'll open the doors, and you'll see there's like fingers that go up between each bag, and they just go back and forth. It's very simple.
Is that a manual thing, or does that,
No.
does that do it all the time?
It's a good question. Every time this unit is shut down, there's a time delay. The time delay is built into the VFD so that the VFD knows when it stops running, because it can't be running because that will suck the dirt right back up into the filters. So, and it's long. I mean, it's, I don't know, maybe 60 seconds. It seems like forever. And then you'll hear it. You can hear it and it's just, and they set them up at the factory, but it seems to me this one was unusually short. There's a timer in there which, if like we'll talk about that in a minute, but this, if you've seen it, they're not working. You know, like if for some reason the dust isn't falling off. One of the possibilities, it just has to be set to run longer. Okay, so that can be done. There's 3 timers in there. There's no literature connected to that timer, those timers. You have to go online, and it's readily available online, and it tells you. But those timers have like 4 or 5 different functions, and it'll tell you. And the wiring diagram, if we had it, it shows you what it's set up now. So that's very good. You can see what it does and what it's supposed to be now. So that gives you a starting point. But if you're going to change it, you got to look it up. It's just too, unless you've done it many times, you're more likely to do it wrong.
Okay.
Okay, so that's this. This is that photo hill that I was talking about. And okay, that makes me think he hasn't gotten to it, because I took it off. And the wiring it's all there, it's just not right. So this is a sort of catastrophic failure indicator. And you can see the tubes, they go up, and one's high, one's low, and they're on both sides of those filters. They're the secondary filters. So when it senses a significant, and it really doesn't make a whole lot of difference where this is, this thing, when we get run it, it'll probably run less than 1, maybe, because they're clean now. Say 0.5, 0.6. Well, anything more than like 1.5 or 1 means there's something wrong. So what I see normally is people just leave it right there. If it has a problem, it's going to be a big problem. You know, it's just going to whoomph and go up, and it'll shut everything down. So when we're testing it, though, that way when I started...
Is that what you set? Is that basically setting the parameter of what
Yes.
you want to say, this is
Right.
okay, and then this is not good?
Yes, that's right. And what I did, when it's operating 2.5 or something like that, is fine. It's really not that critical. It just needs to be set. And not so low that every time something weird happens, it shuts the unit down.
Right.
But what I'm doing is I'm setting it low so that as soon as this thing starts, I'll know from inside that it works, because all of a sudden you'll hear it ramp up and then boom, and the light will go on inside. So that tells me it works. This tells me they didn't change it. So I got to talk to the electrician. This is the Magna Helix, which doesn't have any control function, but you see the tap, and this is low, and it's that lower one up there, and this is across the bag filters in here. And what I would do with this is once it, you guys take it over, and it's clean, let's just say it runs a 1. I would come out here with a magic marker and just draw a line right on the 1. So that way you don't have to think, well, what is it normally or anything like that. You come out and you'll see if it's significantly past there, because remember, this is self-cleaning. So it's going to be higher than that, but not much. And if it's starting to creep up on you, then there's something wrong, and I'll open it up here and I'll show you what you look for.
So do you think that, will the tech who comes in and does the balancing and everything, will he set all this?
No, he won't touch this stuff. All he's doing in this case, as far as I know, is he looks at the engineer, and the engineer wants 170 CFM in the third one to the left of the door. So he screws around with all of them until he gets them that way.
Okay, so this is on us to do?
You don't set it. This is just this tells you, when I leave, I'll just stick it straight up.
Yeah.
Then you may find for some other reason that that's a problem or something else. Then you fool with it. I'm telling you how it works. Then you can make changes. You shouldn't have to ever touch it.
Okay.
But it's obviously easy to change. Or to test. I mean, that's like I'm going to do. You can turn it way down, go inside, turn it on, and all of a sudden it trips again. Well, wait a minute, hold it. Or it doesn't trip when it should, then you know you got a service issue. Okay, and this one is just a monitor. So if you put that line in there, when you come in to do the maintenance, whatever, you just glance at it when it's running, and you can see how it's doing. That gives you a starting point from what you're going to see or not see in here. So, but if you put that magic marker, then you don't have to try to remember what's normal, what's not. I can't even remember my name now.
Yeah.
So it just makes it a lot easier. This is where the dust ends up. Now, what you'll do is this opens up, moves apart, and then it separates this from this. Okay.
This is the point where I will handle the cleaning of the barrels.
Yes, this is where
we will have it. We'll shut it down, shut the power down.
Right.
Right. And then we'll be able to come in and undo all these, and this will separate.
Yeah, when you take this off or drop it, then these are separated from the machine. Now, what was done here, I have not seen it done before, but at one level it's good, but I think it may have another problem. When you open these up, normally these things would drop down like 1/8 of an inch.
Yeah,
now,
that's the ones we have at the other school.
how far down do they go?
It's just a
Tiny little bit? Yeah, because normally if you...
because they're elevated a bit.
Well, this one, you can see how much this is elevated. It looks like that's... Take it up, because when I loosened it, if it were loose, you would have seen it move a little bit. And this, I think, looks like a good idea, but because it's rubber, and this could weigh, like 75 pounds, you try to slide it out of there, and because this clearance is really pretty tight.
Is it?
Yeah, but see, it would have moved. If when I opened this up, it would have dropped. Now, what I've seen other people do is they go to the wood shop, and they just get 2 boards, like 1x4s or 1x3s, and they put them under here, and they plane them so they leave about this much of a gap, because this thing will pick that up. It'll lift that much. So that gives you some room to get this out of there. And the wood is smooth, so it'll move a lot easier. This may work very well, but if it isn't, some of these can be just removed. And really, you just get sheet metal. Put a sheet metal at the end, because I think that rubber is going to be potentially not a help. It's going to be a problem. But that's one of the sort of the trickiest parts of this arrangement.
Yeah.
So the air comes in here. Yeah, over here. Yes. So most of the stuff ends up here in these guys. And so for a test, once you can, I would think the first time you do it, you drop them all.
Yeah.
And just slide them out and look and see. Then you get an idea what it's worth. After you've done it maybe once or twice, you can just do one. You can see this one gets the vast bulk of it, or the one in the back gets the vast bulk of it. And that'll just save you some time, and you're just seeing whether it needs to be cleaned.
Do these have windows in them?
No. You've got to slide it out of the way a little bit, and then you can look down in there. And then you determine, well, if I don't do these, every 6 months, after 6 months, it's probably this deep. If I wait that long, it's a battle to get these things out of here. I saw one place recently where they had altered it. This couldn't be done here, but this was it was bigger and it was higher. They set it up, the maintenance people, so they could back a pickup truck under it.
Yeah, we've had those.
It seemed like a good idea to me. So this doesn't allow for that. But this is what you should be, the maintenance, that's the thing that can't be ignored, is these things filling.
Yes.
Now, if the teacher may be interested in this, I didn't notice, are there planers in there? Yeah. The planers make a lot of dust, and if they're actively using planers, these things are going to...
We have a PM to do these during the school year once a month.
Okay. I think you could check them. And you may find that it's so much simpler doing once a month when there's 6 inches in there than to wait once a year and have it almost filled, and then 3 people are fighting with them.
Right.
But that's something you guys got to do. And it's the thing is, the no plan doesn't work.
Right.
Any plan, you'll figure out a way to do it.
Yeah.
Okay.
Yep.
So and it's typically going to be in there. They've got a floor sweep, so the floor sweep, pieces of wood, paper, stuff like that gets sucked in, and that'll tend to fall, that'll come in and just fall right down. The paper won't. So come around here and I'll show you what you're going to deal with that. Is the one you have the other place, is it an American Air Filter? Or is it the same brand? Or is it a different company?
I'm not sure.
Okay. Yeah, okay. All four of those are supposed to be tight. Now, you're going to have to, your machine, come over here. This doesn't open all the way. See, it's got this restraining thing. And what this is, and you could bend it out of the way if you want it. This is for when you have to change these filters. These filters are service items. They're not maintenance items. I mean, you could say, I've heard people say 10 years. If they don't get wet and somebody takes care of them, and I'll talk about that in a second, they take care of their, they're just fine. They last a long, long time. So it's not the kind of thing where, yeah, I'm going to have to change these every 6 months. And I've heard people say 10 years. Okay. It's probably not 10 years, but the idea is it's a service issue. Gotcha. Now, if you look in there, you see the gray goes all the way across. They're the fingers that I was talking about. Like I don't have my flashlight, but you can see there these fingers stick up. When you change it,
Turn on
Without 4 alarms. Which one?
Turn on flashlight.
Actually, I probably got mine. Okay, there you go. See the way it sticks up between the bags? You see what I'm talking about?
Yep.
Okay. So, and that's what shakes it. This thing goes back and forth, and you hear it, and it shakes the whole operation. If you're going to replace these, that rubber piece has to be removed because it's got a grip on these. And you'll see the pin. There's a pin there that's designed to be pulled out, what do you call it, Clovis or some kind of pin. And that threaded piece there is an adjustment to move these apart. So it's set up to do that. It takes a little bit to look at to see, well, how does this work? But it's doable, and there's like 4 of them in there. It's a job. And now see, here's this handle here, and there's a handle here. Those get pushed. So let's see, how do they go? I think they get pulled out. Yeah, they get pulled out, and it lowers the bag. And then if you've lowered the bags, you've taken out the fingers, that'll just slide out. Now, to slide it out, you got to get it past this door, okay? So that's where this thing comes in. These hinges are just the type that if I were to push up on this thing would fall off on the ground. You try to put that back on, particularly if you're alone, this thing weighs like 25 pounds. Now you're trying to get this thing aligned and it won't align. That's what this does. And probably a service guy designed this because it seems like a heck of a lot of, somebody going out of their way for something you only encounter, once every 10 years.
Right.
So I've seen people bend them out of the way. But then it's there when you want to put it back together, you can rest it on this and it pretty much aligns itself. You can just drop the door on. Otherwise, it's just you're up on a ladder, you're fooling with something, you're ending up on your head. So, but to get them out, this has to come off. It easily comes off. Just lift it up, put it out of the way.
So this will just slide up, right?
Yeah, see the hinges can you see those hinges are just pins. They lift straight up.
Yep.
And then all 4 of these are closed. And let's see what else is in here. Oh, okay. Now, paper is probably going to be one of the worst things. The paper ends up getting sucked into that, they're cleaning the floor and somebody doesn't want to pick it up, or they throw the paper in there. And it comes in here, and it's going to get drawn up between this. And then the paper doesn't want to fall out because it's jammed in there. Then the dust starts to accumulate around the paper, and pretty soon it's blocked. And that's when that's one of the things when you're maintenance, when you come in, you just open these doors and you look and make sure you're not building stuff up. And then, like I hear people say, they use a broom handle or a stick they just have it just laying here. You just put it in, and but if you wait, and then if there's any water, then you have all kinds of problems.
And it comes
So,
to taste and-
yes, so it's again, you just have to look and determine, we got to check this every month, or this is one thing, we got to just take a look in one door, you'll get the idea real quick if it's not working as a general problem. But if there's a specific problem, we have one kid when nobody's looking, it's throwing all kinds of paper in there, and it's jamming up the whole thing. Then you may have to look. The first ones would be the ones. Then you'll see the pattern yourself when you look. You know how this equipment works. It's these things, like a lot of this stuff, it's location specific. You know, it depends on the teacher, the curriculum, a whole bunch of different factors, and the people that take care of it just have to learn what this machine is like. You'd have 5 of them in a row on the side of a building. They'd all be different because whatever process was involved has a different operation pattern. Okay, so you got to look. Now, if we look up there, I can, let me climb up on that ladder, I'll open that door and see here we go. I don't think you have to look at these things. Great, now I got to be Spider-Man. Great. Damn it. The gasket is sticking, and I don't have the strength. My shoulders have decided years ago they didn't want to work anymore. I think I'm going to have to move the ladder here. Now that's loose. Let me try something here. Yeah, I just need to get my hand under there. Damn it. There we go. Okay. No. Can you see in there?
Yeah.
Okay, is it metal?
Yeah.
Yeah, okay, it's a metal mesh. I think I saw on one of them it wasn't metal mesh, and I couldn't figure out what they were up to. So they may have an alternative. Nobody's told me anything about this, but I've seen other ones where they have a rather fancy filter remote from the unit. It's a really fine filter. Those bag filters aren't going to let much through. That's their whole job. I mean, so they don't really need a second filter. But they may have a deal where you can put special filters in here that are more designed to clean the air rather than protect the equipment. But as you can see, this really isn't designed to come apart very often because it's got the rain shield so that you can't lift it off the hinges. So this is something that, mostly this is just to understand what's here. You don't have to deal with it. Now, if the thing stops because there's crap has been drawn up into it, well then you're going to have to get ladders and, fool with it. Okay, we can sort of see it from down here. There's another sound attenuator under the blower. And you don't have to do anything with it, but that's what the light gray, that's a sound attenuator. The motor above, you see it's a direct drive motor. It's got Zerk fittings on it, and there's probably some schedule. My experience with that is that everybody, I've quoted like 3 or 4 manufacturers on different bearings, and you may have done the same thing. They all have some story. And the fact that they're all different means if you do anything, it works fine. If there was some clear problem, they'd all do the same thing to take care of the problem. But again, you have to have some of your own schedule. Once a year, you give it a couple squirts.
Okay.
So you'll just have to figure that out.
Up on the yellow.
Yeah, right. You see the top of the motor. And that's why the VFD, in my opinion, has turned out to be a good thing. It's probably cheaper in the long run to put that VFD in there than have a balancer spend 4 or 5 hours taking bearing, pulleys off, testing it, putting a new pulley on, and fooling with it. It could be a whole day. That's 5 minutes.
Right.
So, okay. So let's see. Oh, Now look up there, you see the abort damper?
Yep.
You see that handle, which is now nicely positioned on the conduit? That should go all the way down. So the way it was the other day was that the conduit was bent or angled in a different way so that that arm hit it when it was much higher. So I can't believe the guy I spoke to did that. So it might have been somebody he told to do it, because you can see it doesn't close all the way. So what's the point? So if it's working right, you can see the conduit goes up there, and the conduit goes to a solenoid. And when this thing goes, when it is engaged, you'll hear the solenoid zzz, and that just opens, and that thing just comes down. Now, putting it back, particularly like this, is what I see people doing, is they'll get a stick. Now, this is higher than most. They'll get a long piece of wood with a V in it or something. And if your shoulders work okay, so you can control a long stick, you can just push it up. And when you push it up, and it's not, activated and buzzing at you, it will latch. I've never had a problem latching it. I've never heard anybody say there's a problem with latching them. You just have to push it up.
So up is the running position.
That's correct.
And when an issue comes up, boom.
It falls so it's on a 45-degree angle.
Okay.
And it diverts the air out that opening and out that way, and presumably smoke or whatever is happening. And we can test it. That machine will test it. It's not going to test that because it's already tripped, and when the person did whatever they did, they didn't bother resetting it. So I'll be talking to them here in a little bit. But that's the kind of stuff I was talking about earlier. So something we can't test because they still don't work. But you can see what it will, and it will work. By the time I finish today, all this stuff will work. Okay, so now we can go back and give it a run. So, and these are the two disconnects. This is for the shaker motor, and this is for the blower motor.
And so when we come and take this off, we can just...
Yeah, and that carries all power to this booth, all the high voltage. It doesn't disconnect like that guy's still active.
So
And
this
that,
gives us the opportunity to take these out. And
yes,
you get
just so you don't have to worry about it starting when you... All right, we can turn it on now and see what it does. Oh, here's the... Were these laying there? Here's the drawings. I didn't even notice it. Okay. So...
He's on the mobile phone.
Is he coming back? I should wait for him. But anyway, there's another thing, which I don't know, it seems to me, I don't know whether it's the electrician, I don't know whether it's hooked up or not. But what this shows, and I'll tell him too, these are field wiring.
Yep.
For each one of these things, they're supposed to turn the equipment on.
All right.
There's a jumper in there, which I saw, and I think it's the jumper I told him because this wasn't hooked up. I may be wrong. We'll find that out in a few minutes.
All right.
But this is something that has to be either, well, occasionally people don't do it, but my understanding, I regularly remember now, there was talk about what they were going to do here, but I haven't done it. Here's the wiring diagrams. This stuff was laying here. I didn't even see it. What we were just talking about is these are circuit current switches. And this is just typical. I don't know whether they're going to do each one. Some places do that. Other places do a single panel, handles them all, and you just put one, and any one of the breakers will trip that. But that's something that someone else has to design. And I don't know, I don't think they've done it, but we'll find that out. I'll find it out when I talk to them. So there should be a jumper in place there that just connects them just as if, and we can make it work. But let's see what the other, here's the VFD, there's the photo helix. All that stuff is here. This is something that valve thing, the reverse valve, that's unusual. I've seen like 3 of them. And this where I couldn't find how it was wired in. And it's tucked up here in the corner is the breaker, the contactor in there. And I think they got that working. So anyway, if you can't read it, you got to get it with good light. But these are the time delays, TD, that I was talking about, and there it tells you all the settings, which you'd be there for a year trying to figure them out without you know, there's something telling you.
Yeah.
So, and this is actually pretty good. This is a sort of a block drawing, which shows you what's here. There's that main panel, there's the photohelic, and it shows where the wires, you know, go, and it's real helpful for this, when you're trying to put this thing together. Here's the abort damper, and you see the abort damper, that's wired to the spark panel. And the spray nozzle, the spark panel. There's 2 spark detectors go to the spark panel. And the shutdown goes to here, goes into the main panel. It doesn't show the incoming power. That's what I think this is there. See, that's the electricians did that. That's where it hooks in. That's where the disconnect.
Southeast 147th Avenue towards Southeast 14th Street.
Google Maps, still.
Yeah, I didn't turn it off, I guess, when I wrote up here. Oh, man. All right, whatever. Okay. See, and here's all those current switches. There's, in this case, it shows lots of them. It just depends how many you have and how they want to do it. Well, I'll talk to them, but what I've seen happen by accident is they'll have the wall switches will be in the same panel. And then somebody plugs a battery charger into the wall switch and everything turns on and nobody has any idea what's going on. So they've got to decide what they want to do ahead of time instead of just wiring it and then it does whatever it wants to do. So that took a little while to figure out that. Okay, so this is the wiring diagrams. Let's see. Oh, that's the sheet metal die stuff. Let's see. Oh, yeah, they blew up the manual that's over there, and that says manual. This is the wiring for the electrician. This is all the electrician stuff, I guess.
Yeah.
And that's what's inside there, and we'll, you know, I'll point out that stuff when we're actually doing it. And here's the. Okay, the electrician doesn't do the firework, so the fire connectors are not noted. So these are just the electrician's paperwork. Okay, let's see what happens. So, was it Brian? Brian, okay. You want to turn it on? So open the door and turn it on at the panel. You know, at the main breaker. This guy. So just right down here, yeah. You just do that. You just go all the way over. Okay. Now it wakes up. And there's no, that is the motor starter. There isn't a motor like that. That motor starter over there is for the shaker motor. This guy does all of it. The main power goes into that, and then the power comes out of that and runs to the motors. Now, when I was doing it, as far as I'm concerned, it's set up. I don't know what's happened since I've been here. Now, the fact is, restore backup. That's what somebody left it, so who knows what it is now. Okay, now, on this, you shouldn't have to do anything. One thing that would be something somebody, you or someone else might try, is if they're having problems, put this on hand. And then you can, I'm saying, the people who do it, you shouldn't do that unless you're real clear about what you're doing. Because if you put it on hand and walk away, nothing works. This has to be on auto, which is, you know, this guy, which it says up there in the upper area. Are you familiar with ADV?
I am a little bit.
Okay, well, good. I'm used to them, so for me they seem obvious. But
This whole panel will probably, if anything were to go wrong in any of this, would probably come to me.
okay, well, then you can use the hand, but you can't leave it in hand.
Nope.
And it's because it won't work. So I fooled around with this the other day, and as far as I'm concerned, it's the fact that some things didn't work. It was set up right. Now, when I actually try to do it, when they get everything figured out, they turn out I have to do it over. But I don't know. We'll see right now on this. Let's see. Okay. Yeah. The way they control this, what the balancers do, I'm surprised I haven't gotten phone calls about it. So the balancers must be used to this. They did something, in my opinion, was unusual in that, let's see what we got. Let me get rid of this. Okay. I want hand, and then I want off. And then I want next. Oh, here we go. It's probably going back to the default position. I have to do it over. Shoot.
So you have this stuff in your AC units and stuff?
Yeah, we have stuff like this in our air handlers and stuff like that. So I'd say probably a good portion of the VFDs throughout the district are ABBs.
They're real common. I like them. They're nice.
Our boiler pumps and our chiller pumps in our mechanical room have this same exact kind of drive.
Okay. Yeah, this is the next generation. They've been around for a couple years.
Yeah.
Okay, so you see down here, that's the input that's coming from presumably an external source to drive the drive, and it's 10 volts. Well, the way they do the controls is the guys who build this, they wire the power supply from in here right directly into this controller, so that it's reading full load all the time. And then what the balancer will do, he'll go into the menu to go to maximum minimum frequency. And if he decides it's 57 hertz is where he wants to be, or she wants to be, they set the maximum at 57 and the minimum at 57. This is calling for full whatever, and that locks it in. So it's an easy way to do it. It's also, it keeps somebody else who's not familiar with it from going in there and screwing around with stuff. Because you won't be able, if you know something, you'll eventually be able to figure it out. So, but that's why this is full. But full will mean whatever the maximum and minimum have been set at, and they set them at the same thing, at 57. Typically, they're on the high, it's engineered rather closely, and the ones I've seen, they'll be 55 to 60 hertz. You know, that they put a motor in that'll just do what they want it to do, no excess. Okay, so that's that. What was going on here, some of this stuff, one of these the time delays bypasses that photo hook to give the unit a chance to stabilize before it actually decides whether there's a problem. So that's one of them. One of them's the shaker motor. It says on the thing what they do. And that is how long the shaker motor will run. There's a third one which I can't think of at this moment, but I will. This, I think I remember what this is. This was bypassing the no return valve because they hadn't mounted the sensors, among other things. So that had to be allowing the unit to run. And since it wasn't put together yet, it was, so that this jumper has nothing to do with those current sensing switches. I thought, because I'll do that one myself. Okay. And I make it big so somebody later can see this is a jumper. But I remember now, that bypasses that valve. So I could actually pull that out. Well, for the time being, I won't, because we can't test that anyway. Right. You got to have the airflow going in the wrong direction. You can climb up there. I've done that and force it to work. And maybe before I leave today, I will. But right now, if they got a lift, I might do that. This says, I asked them about this. I forget. Oh, this is something the electricians did because they said they were used to a switch that, maybe you're familiar with this. They said on other motors that they see, there's an auxiliary switch. That's right. Now it doesn't make sense what he was saying. It was like an auxiliary switch on the motor starter that tells the drive that it's okay to run. That some other source is, like it's a secondary drive or something. And since they said they couldn't find anywhere to hook it in, so I figured, and I've never seen it. So it's probably a usage that they're used to, and I'm unaware of anything that would trip it. This is the motor starter. So at any rate, I don't know what the story is on this. That has some control stuff, and I'm not sure what that does. It's not connected, I don't think, to what we're doing. Okay, so that's from the building system. I don't recognize that. These are, like in this case, CR2. I don't know, that might be the photo hook. Here, you can come over here, you can see. This stuff is getting smaller and smaller. somewhere in here, there's CR1, and we're looking for CR2. Oh yeah, that's the photohelic relay. Now that's pulled in, and that's normally closed. That's weird. That's the way it's supposed to be. So maybe the electrician may have changed the wires. It may work, but he wasn't sure enough to close it up. Figuring I'll test it and we'll see if it works.
All right.
So that tells you that relay is functional. Just like what we did. We got a question, and you look, and it tells you it's working.
Yep.
So you don't have to put your meter on it and then try to figure out what it does. Okay, so you wait for him. Have him turn it on, and we'll see what happens.
All right.
These current sensors, these things are from the building system.
All right.
Because I don't know what they, but let's see. Is this building being commissioned as well?
I think so, and I'm not sure when it's going to be.
I'll push it's on local, so push start, and then CR1 is the main control relay, so
Okay.
that worked, but nothing's happening. Okay, so let's take a look at the wiring diagram. So we have power. Actually, we don't know if we have power. Let's see. We know we have power because the power comes from, main power comes from here, goes out to that disconnect, and the disconnect is on. So I can put my meter on it, but I'm pretty sure there's power. So let's take a look. We'll see why CR1. Okay, now CR1 has all the stop-starts connected with it, and it also, let's see, is CR2 going set? Yes, it is. CR2 is the photohelix, so we know we have power to there.
Should we put the VFD in auto? Because it's an off right now.
Ah, okay, there it is. That happens to me all the time. I do something I forget I did. So is it ramping
in
up?
auto now, so
Yeah, but is it ramping? It
Yeah.
should ramp. Okay, that's it. Good. Good. You get an A for that.
Yeah, star.
Yeah, you get a gold star.
Yeah.
Okay, obviously it's working. So you get an idea. Oh yeah. Okay. So one thing that didn't happen is the photo here didn't trip it. Okay, I'm going to go out and look at that needle to see if the moving one is past the set point. So I'll be right back. That's that damper. Because it's not all the way down, it's bouncing. Okay, well that doesn't work. He didn't wire. He hasn't changed the wires. All right. So that should have shut it down, but we can pretend it did, and then we'll go on. Basically, that's all that happens here. All right. Now, you go over to these other guys and fool around with them. I don't know, were you here when I was explaining this? Yeah. Okay. That's about this in one of those things. Okay. So internally, this thing seems to be working all right because we don't have any dust. We know that, and that damper is not. the damper is not locked in place. So this apparently, when they wired it, they wired it right. And the jumper is jumping the connection. I think it's this guy actually. This should shut the unit down, but it's blocked. Okay, so this thing, see if it's lit. Yeah, you can't really read it. This says service mode, okay? Now when you're fooling with it, see that toggle? You should put it into service because that allows you to check each component individually. I think the first ones you check, and when I'm going to do this, I'll show you do it. It checks the spark detector. It will do that in normal mode. That's the only one you can test. You can't fool with the rest of them. So, when it's in service, it actually throws these relays. So it doesn't do them like instantly when as if it had a fire. Okay, so once you push the test button, once you do it, you'll do the test, you're going to push the test. Okay, now, so it says test detector 1. One of those two, and it makes no difference, is designated 1. Now, if you push execute, what it did just now is it set of beams right across from each other. One shot a light beam into the other one, and it detected it. So we know that one works. Or that they both work to some degree. So now hit next. Okay, your finger bumped. So just, okay, we'll go back. Hit the last. One again. Okay, so now do execute. Yes, now put next. Don't bounce it. Whoa. No, I had trouble with this when I was doing it. Yeah, I don't, if it continues to do this panel may have to be replaced. We'll just see it, yeah, hit execute. Okay, so the two that we're using, pass. Occasionally they have it set up so there's a couple main lines, so put them in those lines. So hit next. Okay, and it tells you whether it's available or not, and hit next again. We're not using it. Okay, now this is a spray. It went by one. So let's say, see, there's something odd about that. Now, we did this the other day, and I don't know whether it was been tested or not. You know they test flow in this system? Get the flow will set it off. Some of the systems, they test, if the water starts to move, that means there's a fire somewhere. So, I've tested it, so I know it works. And it runs for, I think, the test mode is like a half a second or something like that. There's a considerable pressure on those things. It dumps a lot of water all of a sudden. Over here is this matrix, and these are all open, closed. It tells you for each of these things, and here it says spray. 2 seconds, 5 seconds. So in this one, it's 1 and 2, switch 1 and 2. It's these two which are hard to read. So it looks like it's off and on. So it's off and on. So the real thing is 5 seconds. That's the way they are. But you could go, if it's 30 seconds. And some of them, you go over further, it will continue, it'll do it again and again, depending on how it's set up. You shouldn't have to do any of this stuff, but that's how this computer knows how many sprays are in there. It knows how many sensors are in there. It's all programmed. So that's what this says. Okay, so let's... Okay, so I'm not going to test this. There's also another spray. Okay, this is the horn. Well, let me try the horn. Hit execute. Now this thing's going to be loud. Now, if it were really quiet, you can come up here and hit acknowledge, and it'll stop it. Okay. Okay, so one of you guys hit next. Okay, now, if you were to push execute on this, it would click, you can hear the relay go, and this light lights up, and then all this stuff happens at once. shuts the unit off. Now, we'll be shutting the unit off here in a second. So, okay, so we're not going to do that one. All right. So hit next again. Now, this is trouble. The last thing on this test is the displays, and it goes through all the readouts. So you can tell, you'll see it'll say no battery or loss AC, they're all trouble. There's a whole bunch of them. So we're not going to do that one either because they got it wired in. Okay, so hit next again. Okay, now this is shutdown. So when you hit exit ahead. So it just shut down the unit, so it works. Now, that happens simultaneously with the horn and the spray, and then hit next again. Now, this is that abort damper. Now, we're going to try, we'll do it now, but what we're going to hear is probably just zzz, it's the solenoid trying to open.
Yep, I heard it click.
Yep. So it's working, but now we got a problem because it's, it's not set up right. Okay, so hit next again. Okay, this is display, so hit display.
So execute?
Oh, yeah, excuse me, yeah, hit execute. Now, what it's going to do, it's just going to run through all the possible screen issues.
All right.
So you can tell whether one's failed. But what they'll do is they'll hit, see, it's all kinds of stuff. There's a number of functions, yeah, you should watch it to give you an idea.
Yeah.
So, at some point, yeah, those things are all trouble. And then it just starts the detectors again, and it should, I think it just stops on its own, but we're going to find out here in a second. Oh, no, I think this said the test was not on the other one. Okay, yeah, it just ran through everything. Here we go. Set time, I've done that. The last thing I do when I set this up is I put the time and date in. So that when it comes up as on normal, it'll say time and date. So I do that so I know that I've done it, So, and that's, the manual is in here. The manual tells you how to do these things. I think the setting up time and date, you just push the first two in. The manual is actually quite good. But like most manuals, you only need maybe 20% of it. The rest of it doesn't deal with stuff you're dealing with. Okay, so there we go. So now we're going to exit. And now it's lit up, and that's what it was saying, but we couldn't read it because it wasn't lit up. So, and I don't know what the normal thing says, but I don't want to fool around with it. There's too many people in the building. These are the batteries, obviously, and they don't last forever. I know that. And yeah, they're in series. This is the power supply, the transformer, or well, it's not a rectifier, whatever it is, rectifier, it's a power supply. Okay, so that's all that. This, let's see, none of these. You shouldn't, you guys won't deal with any of that stuff. They pull out. So you can wire them out in front of you, or you can disconnect them. But if I do that, then the thing may interpret that as being a failure of the system, so it'll do its own thing. This one, we can't really test. This thing here, this controller, they just did this. It's not in the wiring diagrams, at least the ones I saw. And all this replaces all the old relays. It's for cheaper and easier to put this thing in, and I called about it. I said, how am I supposed to program this? The guy says, you don't have to touch it. It's already programmed. It's not part of setup. But you're looking at it, you think, well, what's that for? Well, it just replaced, there used to be a bunch of relays in here, and it replaced them. So that's easy. Let's see. Okay, well that's, oh, well, wait a minute. I wasn't listening for the shaker motor, but when it shut down, let's start it up again. Why don't you try the remote? I'll turn it on the remote, and we'll see if the remote works, and then we'll turn it off, and we should hear the shaker motor. Okay, I'm going to put this on remote. Okay, it's on remote. And I didn't put it back on off, so it's coming on.
All right.
So we'll let it get up to speed, and then you'll kill it, and it'll take a while, and then this will shake. running a class in here. That's why people take clothes off legs thinking it's going to make it quieter. There was a job down in Oregon where the ductwork was operating right at the limit. Did you do that? Okay. So I hope we're here. It was right at the limit, and I told him don't touch anything, leave everything, because I was going to have to go back. Somebody came in and started closing stuff, and it collapsed 30 feet of a 24-inch duct. Half of it was over a closed ceiling.
Wow.
Talk about expense.
Yeah.
Yeah, so that's another reason not to fool around with any of these things. Yeah, as it depressurizes.
Yeah.
Yeah. There it is.
Yep.
Okay, so that works. Yeah. That's a heater. That's the fan, thermostat. In here, you're not, yeah, the fan may be needed. It's set at like, looks like 75. Yeah. So it gets warm, it'll circulate the room air. So I think, I'd like to be able to show you everything, but obviously some of it's not working right now. By the time I leave today, it should be. So if one of you guys can get a hold of Dale, oh no, I have his phone number. I'll just call Dale and ask him. He's the electrician, and I'll find out what's going on. Do you have any other questions?
No, I think we got what we need.
Yep.
Okay, and I'll put my name in here and phone number.
All right.
And you're not bothering me. I like this stuff. This is interesting.